to solve another Leetcode problem. 115 distinct subsequences. So for this problem, we are giving two strings s and t, and we're going to return the number of distinct subsequences of s which equals to t. The test cases are generated so that the answer will fit into a 32-bit side integer. So this is okay. Basically, for Python, we can ignore this because for Python, the number is going to be really big. Yeah, we're going to compare the string s and t. So let me just write the string s. It's going to be rabbit. Yeah, but we're going to have a 3b. And for string t, it is here. It is another rabbit, but we only have 2b. Yeah. So exactly how can we solve such kind of problem? We just need to find how many distinct subsequences of s. So this t is fixed, and we need to find how many. And for this one, we have 3 subsequences because we have 3b. Maybe the first 2b, or the second and third b, or the first and third b. So it's gonna have 3 different cases. So we're gonna return 3. And this problem can easily be solved by using the longest common subsequence. So definitely, if we are going to calculate the longest common subsequence, it's gonna be easy. It's gonna be just this rabbit. So we calculated the length, which is gonna be 6. But for this problem, we are going to calculate how many distinct subsequences. We are not calculating the length. The length must be the length of the t, the length of the string t. But we are going to check how many different cases. But we can still use the same idea, the longest subsequence idea. We just need to change a little bit of the coding. Because for string t, this one, it is fixed. We can never change this t. Yeah, let me just fix it. This is a string t. But for string s, we can choose the sum of the subsequences. We can start from the beginning, or we can start from the adding, or maybe we're gonna start from the add. So this is a pointer maybe j, and this is a pointer I. So we're gonna choose. We're gonna check the character one by one. So if si equal to dj, it means if they are equal to, for example, this t equal to this t, oh, they are equal. But still, we have 2 decisions. For t, it is fixed. But for s, we kept 2 decisions. This means if we define our function fi and j, yeah, we have 2 decisions. The first decision is that, oh, they are equal. We just we just check how many different cases before them, before this j and before this I. So it's gonna be fi minus 1. Let me make it clear. So this is I. So this is I, and this is j. So it's gonna be j gonna be fi minus 1 and j minus 1. So this means we will select this character, and we will select this character. So we're gonna check how many different cases just before them. Yeah, so this is one case. I think this is clear. So this means this t gonna be selected, and this t gonna be selected. We just need to check how many different cases before this t and before this t, and then we just need to plus this t. It will not change the number of the distinct subsequences. Yeah. So another case is that for this t, definitely we're gonna select it. We're gonna use it because this rabbit is fixed. Definitely we're gonna use it. But we want to check how many subsequences from this t for this rabbit, and compare with the subsequences before this t in string s. So this means it's gonna be fi minus 1 still, but we're gonna choose fi minus 1 with j. So we're gonna choose this rabbit, the whole string, this rabbit, with this rabbi, with this one. Because the string s is always longer, maybe we're gonna have some cases it meets this condition. So this is exactly what we are doing. So for example, here we have 3b. Definitely we have some other cases. It's gonna meet the situation. Maybe, yeah, we will choose this b, or maybe we will ignore this b. If we ignore this b, RABB, and this is RABB, definitely it works. Yeah. This is for Si equal to Tj. So what if they are not equal? So for example, this is T, maybe this is I. Yeah, maybe this is let me use another character. Maybe this is A. So this T is not equal to this A, but definitely we can find some subsequences. Yeah, but this T is fixed. This rabbit is fixed for 3T. This T is not equal to this A. So this means if they are not equal, so definitely Fij gonna equal to, so Fij gonna equal to Fi minus 1 and J. Because this is fixed, we're gonna choose to J. Yeah, and here we're gonna choose the string before this character. This is for Fi minus 1, and this is for I minus 1 to J. This is for Fi minus 1 to J. It is for this rabbit. As we can see, we can still find the cases. This rabbit must have some distinct subsequences for this rabbit. Yeah. So this is the idea. If you know basically about the two formulas, definitely you already know how to solve the problem. There are only some edge cases we need to consider. So let's just start coding. So the pattern gonna be, we're gonna define function I and j. Yeah, here I'm gonna give a pause, and let me just do some preparations. I'm gonna prepare the length of the 3s and 3t as R and C, and finally I'm gonna call the function. It's gonna be R minus 1 and C minus 1. Yeah. Now we're gonna start the main coding part. So the condition is that if the edge cases is that if I less than 0 or j less than 0, this is our edge case. So for the basic case, if we are going to calculate the longest subsequence, we're gonna return a 0. But here we're gonna change later because it's not the same idea. It is the same idea, but we needed to change the coding a little bit. Yeah, but I will change it later. So now we have two decisions. If Si equal to Sj, so what's gonna be the final return? Yeah, so we're gonna return Fi minus 1, Fi minus 1, and j minus 1 plus Fi minus 1 and j. So let's just check it from here. I cannot say the formula, but if you remember before, our formula is Fi minus 1, j minus 1, and plus Fi minus 1 with j, because for the 3t it's going to be fixed, but this may be one character before it. For example, this character is a from here. Here we have, here we can see it, yeah. So Fi minus 1, j minus 1 plus Fi minus 1 with j. And if they are not equal, we're going to return Fi minus 1 with j. Yeah, but here we need to change a little bit. So here the condition is that if j is less than 0, so this means for this rabbit we've already finished checking all of them. If this is equal, if this goes to 0, definitely we find some subsequences in 3s which is gonna equal to this rabbit. So this means we're gonna return a 1. We're gonna return a 1. Otherwise, we're gonna return 0. So this is the condition for the edge cases. So if j less than 0, definitely we finished this rabbit. We're gonna return 1. This means we find one case. Otherwise, this means j. Otherwise this means j is not finished. J is maybe j is more than equal to 0. This means j is not finished yet. But for 3s, it had already finished. It means we cannot find it anymore. So this means means we need to return a 0 from here. Now let me just run it. It didn't work. Let me check. So this is one case, and this is 2. Let me think about it. Yeah, I think we need to find 3 cases, but I find 1 case. What is wrong? Alright, let's see. If I less than 0 or j less than 0, if j is less than 0, if j less than 0, we're gonna return a 1, otherwise we're gonna return a 0. If they are equal, si equal to, oh, this is sj. Yeah, sometimes I made such kind of mistakes, I don't know why. Yeah, so if si equal to tj, so we're gonna update the formula. Yeah, now let me just run it. Yeah, if we still use sj, definitely it didn't work. Yeah, now let me just submit it to check if it works. Now as you can see, it works. I think the speed is okay. Basically we need to analyze the time complexity. It's gonna be 1000 times 1000. It's gonna be 10 to the power of 6. That is why it works. I think basically that's all about it. Thanks for watching. See you next time.